A very good morning to you all, and welcome to this class. Today, we are privileged to have a guest speaker. So we all know Allan. Allan is going to take us through the next topic. And Allan, you're welcome. Please.
Good morning to everyone.
Good morning.
Allan, once again, and I just want to rather take you through land cover classification scheme. I have sent also, before I start the class, maybe I should tell you that I've sent some material. There is some very nice channel that basically gives a broad view about this land cover classification scheme. So whenever we're doing remote sensing, the particular steps that we take when rather to process our images. Now, I know very well that you've already done some of these things, but maybe I'll try to skim through them very fast, and then I can get to the land cover classification. So typically, you'll always start with a problem that you want to solve a particular area, a region of interest. And with that, you'll also think about whether this same problem is time dependent in terms of the seasonality. For example, it could be daily or yearly. And then you can be able to think about the kind of analysis you're going to use to solve this kind of problem. So usually you'll pick your data after getting your data, and then depending on the data, you choose the kind of analysis method that you're going to use. But then at the same time, even before you actually get the data, you need to think about the classification system that you're going to use. So we call it a land cover or land use classification system. So how are your classes going to be defined? So it's something that you need to think about. And then you can pick your data for your image analysis. You correct it, some bit of processing, pre-processing, then do some bit of image classification, change detection, or whichever, and rather accuracy assessment, and then you can be able to accept or reject your hypothesis. So the thing is that there are certain things that you have at the rather at the beginning of your work. If you have a problem, you need to solve it in a particular area. You need to think about whether you're going to use, for example, per pixel classification or object-based analysis, image analysis. So those who shall be able to look to distinguish them in the next lecture that we're going to have. Also, you need to think about how you're going to define your classes, and we call that a land cover classification system. So that's what basically we want to work with for today. So oftentimes you've been able to we've been able to use remote sensing products to be able to derive land cover, and this land cover basically describes the natural, whatever is on ground, whatever is covering the surface. So it's the physical matter on the Earth's surface. Now, sometimes, of course, we confuse this with land use. Land cover and land use are different. Where land cover is just a physical material on the Earth's surface, land use means how people utilize the land, socio-economic activities that take place on the land. And here I've given you an example of a recreation area. In this case, you have, for example, a recreation area occurring on so many different kinds of land cover types. For instance, you have sandy surfaces, like a beach, or a built-up areas like a pleasure park. So the pleasure park is basically the land use. Or maybe another example could be if you have grassland. This grassland can be agriculture. So you can have one land cover classification system and you have so many land uses for it. So once again, land cover and land use are very different. So for us to be able to define the land covers on the land uses on the Earth's surface, we need to have a reference kind of system, a rather reference system, so that all of us can be able to understand ourselves. In that way, we have a land cover classification system. This land cover classification system provides us with a means of standardizing the way we define the land covers. And the reason why we need to standardize them is because you classify an image and you define particular land cover classes. And I also do it in maybe in another, on another, rather than the same image, rather than the same area for another year. We should be able to have this data comparable. The land cover classes should be comparable. So if you want to do a change detection over two images, then it should be very possible for you to compare the land cover classes. So that's why we basically have a land cover classification system, that it provides us with a reference on how to define land covers in on a surface. So a classification basically describes some kind of systematic framework with names of classes and criteria used to distinguish them. and the relations between these classes. So in other words, you try to get these information classes or land cover classes, and then try to assign them some kind of meaning. You should try to classify them according to some kind of meaning. And in this case, you have to define the classes, make sure that these definitions are very clear, precise. Possibly you can quantify them, and this should be based upon an objective criteria. So that's what basically land cover classification system is all about. Now, whenever we talk about a land cover classification, define these classes, but these classes can be defined at all levels, and they should be independent of. A land cover classification system should be able to work at, for example, large scale or even at a small scale. And then also it is source dependent. So it doesn't matter how you collect your data. What matters most is that the satellite, what matters most is that you have just this land cover classification system that defines classes. It doesn't matter whether you get the data from satellite imagery or aerial photos or field survey or a combination. Now, this is what exactly I'm talking about. You look at these are some of the classes. When you classify an image, you define some classes that are in this. And you notice that these classes have a particular kind of, you see evergreen, deciduous, and maybe broadleaf, something like mixed forest. These have a meaning. So you have to define what is a forest in this case. For example, a forest defined by the National Biomass Classification System here in Uganda could be different from a forest that's defined by the FAO land cover classification system. One of the systems could say that maybe a forest is where you find trees and they're above maybe 5 meters. Another one says a forest is one where you find trees which are maybe above 3 meters, the canopy is above 3 meters. If you have people classifying this data and are using these different classification systems, you're going to have issues if you're going to combine these two data sets. Now, you should notice that in this case, we have one classification system that is being used to define classes at different scales. So like I told you, it should be very possible to define classes independently of the scale. So in other words, at this scale, you could have some kind of classification, some kind of legend. The legend will always change because the legend is dependent on class scale. But then the land cover classification system will always be this. So here on the left, just maybe to clarify again, here on the left, whatever is here, these are classes defined in the global land cover classification. So they are defined, for example, deciduous broad forest. They have a way they have defined them. So you need to check their document and look at the definitions, what they call deciduous broadleaf forest, for example, what they call mixed forest, what do they call croplands. And then you do your classification at any scale, and then you'll be able to get a legend. There are some classes that will appear, some classes will not appear. So it will always be dependent on scale for the legends. But for the classification system, it is independent. So I've already talked about the legend, but a legend is basically an application of a classification in a specific area using a defined mapping scale and a specific data set. Therefore, a legend will always have classes that are a subset of this bigger classification system. So a legend is also scale dependent, and of course also dependent on the way you create your the way you choose to create your map. So the cartographic depiction basically affects the way your legend will look like. Then also a legend is also dependent on the data methodology. So the way how this legend will look like, it will always depend on the data that you have as well as the mapping methodology. So we have various land cover classification systems. So of course you could be asking yourselves, why are we doing these land cover classification systems? And there anyone that we can be able to use just one and everybody uses it and we solve the problem? I tell you there are so many classification systems and people choose them because of different reasons. It's not easy to have one classification system because these classes here sometimes for particular applications or particular reasons, they could be very broad or they could be very narrow. and that they cannot be able to encompass very well whatever you want to classify. So there have been several initiatives trying to create these land cover classification systems. We would like just to classify them into three information scales. So there are some land cover classification systems that have been created at a national level, others have been created at a regional level, others have been created at a global level. So these are just different initiatives at different levels. For example, at a national level, we have government agencies or institutions that collect land cover data, and they have managed to create a classification scheme to suit their data, that national scale. And typically, they always create their data basically at scales of like 1,000, rather 1,000, rather 10,000 or 5,000. Between those kinds of scales. Then we have also land cover classification schemes that have been created at a regional level. There are those ones that have been created at scales ranging from 250,000 and 100,000. So these guys always use this second generation. They always apply this kind of land cover classification on this second generation sensor data, second and third generation sensor data. For example, Landsat. If you have a Landsat image and you want to do your classification, then most likely it's very good to look at these regional level kind of classification scheme. And then we have the global land cover classification schemes or systems. So these have been created at that scale, the global scale, and usually they refer to scales basically lower than 250,000. Now let's just have a look at the examples. Here we have the land cover classification. For example, in China, they have this national land cover classification system. During these years of 1984 to 2007, everyone was expected that if you create, for example, a map, or if you try to classify a land, rather an image, then the classes that are defined there should look like the classes that are in this system here. This classification system. The US has had the National Land Cover Data Classification System. It also has the Anderson Classification System. Then we have, for example, in Mexico, they have this system, that's the National Institute of Statistics and Geography and Informatics. And then in Uganda here, we've had the National Biomass Study. Maybe when we talk about classification systems, very good to talk about our own country. So National Forestry Authority has been able to basically have some kind of classification system that they use to be able to define land cover. So in this classification system, the National Biomass National Biomass Study, they've been able to describe classes. For example, they classify the classes rather based on land cover classes. So for example, it can be open water, built commercial, wetland, grassland, bushland, woodland, and for example, tropical high forest, well-stocked coniferous plantation, broad-leaved plantation. Then for water, for soil water, they basically classify it according to seasonality. It's seasonal or permanent. If you check, for example, the wetlands under when you get into another hierarchy, for example, at a higher hierarchy, when you check through the wetlands, you realize that they classify wetlands according to land cover classes. For example, they have wetlands that are grassland, wetlands that are forested, wetlands that are open water, seasonal, permanent. So they've been able to classify their classes just that way. What does it mean for us? The implication is that if you're going to classify your image, you don't just wake up one day and say, oh, I think I should define my classes as the artificial surface or urban area, something like that. You don't just wake up and do that. All you need to do is to come to this classification system, and then you see the definitions of what, for example, woodland is, and then you can be able to look through your image and then say, according to this definition, this land cover classification system, rather this land cover class occurs here. Then you can begin with your definition of training sites and then be able to do your classification thereon. So this classification system, like we already said, is just at a national level, but there are other classification systems and you need to make sure that your classification system can be translated to other classification systems, or it can be comparable to other classification systems, so that if you create data in either of these systems, it can be harmonized. That's why it's very important to know about the classification systems. So to say, a classification system is just like a standard on how you should define your land cover classes or your land use classes. rather in your data. Now there can be different standards. And in this case, we have our NBS, and there is the land cover classification system on the right-hand side. That's another standard. See that these standards, basically, they are different, but some aspects they are comparable. Now, at a regional level, there are some classification systems that have been created. For example, in the whole of Europe, they have been able to create a land cover classification scheme that if you're going to have to define land covers, you have to use this Corine land cover classification. So if you download all their data sets, you'll find that all the land covers have been defined according to these schemes here, rather according to the land cover, the Corine land cover class. And the reason why they do it for those 27 countries, for example, is to make sure that all these countries produce the data in one scheme and can be rather using one standard and can be comparable, or it can be combined together. Now, we also have the Africa land cover classification system, which has been created by the FAO and it's being applied in Africa currently. So this is the same land cover classification system that is currently being used by NFA, National Forest Authority. So they've actually tried to adopt this one. And the good thing is that it has some bit of comparability. So I tried to ask a friend in NFA, and he told me that because the donors these days say that, so FAO is supporting some of their works, and so it has dictated for them that they should report using the Africa land cover classification. And that means that if there was any data set that was created using, for example, the NBS, you need to make sure that you harmonize Africa land cover classification scheme that's being piloted at NFA. We have also the, for example, in Asia, they have their own land cover classification scheme that covers all Asian countries. And these are basically 9 countries. And then also in North America, they have also some kind of land cover classification scheme that they use. That's basically at a regional level, that these land cover class, these initiatives to standardize land cover classes have been. So here is an example of the FAO land cover classification scheme that I've been talking about. This is being used basically in Africa, and we have classes being defined as either vegetated or non-vegetated. For example, if it's vegetated, is it terrestrial or it's aquatic? And then when you get back to the hierarchy of terrestrial, you have for the vegetated areas on the Earth's surface, then you have something like cultivated and managed areas, then others are semi-natural vegetation. And then at a modular hierarchy, they have been able to further go into the classes and create smaller. So this is basically the FAO land cover classification scheme. And at a global level, we've had these classifications. So for example, you have the USGS land cover classification. We have the gold land and forest cover classification. And then there is the Department of Geography at the University of Maryland. They've also created the classification system. So if you check their data, you realize that they have classes that are classified in a particular way. So don't wake up one day and say, I think these guys did the land cover classification and maybe their land cover classification doesn't look like mine, yet you've used another classification system. It's not easy to compare 2 images classified at the same time using different classification systems. So sometimes you realize that because this land cover classification system, land covers are classified differently in different systems, there are some kinds of mismatches that are introduced. So for example, you have the FAO land cover classification scheme, and for them, they just have natural or semi-natural vegetated areas. But then when you get to this land cover classification system for Southeast Asia, you realize forest has been defined even in much more detail. Then when you get to this other classification system for Indonesia, you realize actually defined forest in a different way. Now that means that if you had data in this different same image, but defining classes in that image based on these different classification systems. Then at one point in time, if you want to do, for example, change detection for that same area, for the different images that you've done, rather classified the image, the information in, it's going to be a little bit difficult. Maybe let's take an example of this. Assuming you have this area and you've used some kind of land cover classification. So in this land cover classification system, you have, this is the global land cover classification system. And then this other one here is the one from the University of Maryland. You notice that basically they have different classes. Classes are different and for the same image. So you need to give that maybe they could be defined differently. You need to make sure that you harmonize these two land cover classification systems so that the data is comparable. So maybe another example is you have the Anderson land cover classification system that's used in the US. Look at it very well. Just look at, for example, urban or built up. They define it as residential, commercial, industrial, transportation, and so many other classes. Also, you have the agricultural defined in this way, having cropland, pasture, many other classes. If you move back to, rather, if you went to another class like the Quran and you try to look for example, the urban or built up, they don't define them as urban or built up. They define them as artificial surface. So that means that if you're going to classify an image and define the information classes in that image, for Quran, the classes will look different as compared to those ones in the Anderson. If you look at wetlands, for example, the wetlands in this case are defined as inland and coastal wetlands, and then they go into define the wetlands as marshes, pit bogs, salt marshes, salines, and intertidal. If you get to the Anderson classification system, wetlands are just classified as forested. And then I've told you, for example, in our national biomass class, wetlands can be classified as permanent or semi-permanent, rather seasonal. And then different wetland classes are defined using the land cover classes. For example, they'll tell you there is a forested wetland, there is a grassland, there is bare. So that's how they define them. So you realize that the information classes, according to different standards or according to different land cover classification systems, can be defined. Now, that has implications for us. Maybe I'll just tell you, there's a time we're working on a certain atlas for wetlands, and then we were in this meeting and we spent maybe, still remember, we did like 3 meetings. 3 meetings, each and every time would come, the definition of a wetland would change. The first time, someone had a classification from the Ramsar Convention. They have a way how they define these wetlands. Next time, another guy came and said, no. These wetlands can be defined as inland marshes, pit bogs, salt marshes, salines, and floods. And he says that that's how the Atlas in Kenya defines these wetlands. So we should use the same classification system. And then another guy comes and says, no. In Uganda, we just use the National Biomass Study classes. And therefore, we classify wetlands according to land cover classes. So we say a wetland is permanent, and then we say that maybe a wetland, grassland, forested, open. So that's how basically they define these wetlands. And we spent all the 3 meetings. I just noted that, this is my opinion, I noted that it seems as we're seated there, none of us was thinking about the fact that we needed to define a classification system before we start even representing these wetlands, before we start generating maps. And we needed to first think about it from just on the drawing board before we started even writing, because now we're at the stage of writing and creating maps. We should not have thought about it later on. And of course, at the end, we had to use any of those systems, and it was the National Biomass Study. Now, there's a possibility, maybe just telling you another story. This is a story, a typical story. So I asked a colleague how they generate their data for land cover classes in Uganda. And he tells me that previously they used to use the NBS classification system the way it was. That's how they used to report their data. So they create for you a land cover map and has classes defined according to the NBS classification system. Then somehow FAO comes in and says, okay, we are supporting you to be able to generate a land cover classification system, but it's very good to use this regional land cover classification system for the whole Africa because of the benefits. And so they also generate land cover classification. Now, I asked him a question like, for example, I wanted to know the change from 1990 to today. Does it mean that I have to go back and classify all these things, all these classes, rather land covers, using the same classification system? He said yes. And my thought was that if you have to go back and create other land cover classes, then the work is too much. You should use the data that's already existing. We can't use the data that's already existing to be able to, for example, do a land cover classification, rather a change detection, because this data is not comparable. The classes are defined differently in these land cover, rather in these land cover maps. What that means for us, it means that we need to just move away from just standardizing the way we define these land covers, harmonizing these land cover classes. So if we want to make sure that we can be able to have these land covers be able to talk to each other, these land cover classes or these land cover data sets, be able to talk to each other, so that maybe we can do complex kinds of analysis. You have to make sure that you do some kind of harmonization. So there are different ways how harmonization has been done. One of the ways how harmonization has been done is that we have already international organizations that have been creating standards for terminology. So they define terminology. For example, what is a forest? So everybody who is going to understand a forest will understand it the same way. Now, maybe I could give you this example. When you go out, when you move out, for example, of technology, or maybe when you go to Kampala, move around the town, or when you look down in Katanga or Chikoni, Katanga, and you might call it a slum. But by what definition do you call it a slum? Sometimes, if you read a particular definition, it will tell you something's a slum, even when you actually never expected it was a slum. The thing is that you need to have always a definition that tells you what that thing is. You need to basically define the qualities or the properties of that thing, so that you can be able to have a standard way of encoding it. So these organizations have defined terminologies to be able to, I would call them glossaries, sort of like. So they have glossaries or thesauri to be able to standardize the way land cover classes are defined. Now, another way of harmonization is semantic. So you have two land cover classes, and then you can be able to match them based on the semantic interpretation of those land cover classes. So you match them based on the similarities, the differences that basically are within these definitions of the land cover classes. In the first one, what was happening is that you just have definition, and this definition is just it's just like a glossary. I would call them, for me, I always call them like informal definitions, sort of like informal knowledge. I'm avoiding to use some word. I'm avoiding to use the word ontologies. The informal information classes, sort of like. So you have some sort of like a terminology that's set, and this terminology, all of you have to use it so that you can achieve similar results. In the second one, all of you have your data defined according to different terminologies, different standards, and then it's very possible for you to match them together. You match them. For example, if someone defines that forest is anything that has trees above, with a canopy above 4 meters. Another guy has the standard that says a forest is anything that has trees that are above 2 meters. So you need to get a way how you semantically define these standards, and then you can be able to match them. When I talk about semantics, semantics is basically the meaning of terms. So you have these different classes which have different meanings according to a particular standard. These two standards are basically compared, and similarities and differences can be deduced from them. Now, the other way is just to translate the legend. You just keep one land cover classification and then change the legend of another land cover classification system to suit this other classification system that is your base. So those are the three ways how we can harmonize these land cover classes. Now, of course, there are issues with each of them. There are issues with each of them, with each of these methods. Now, one thing that you should notice about standards is you being able to create a standard does not mean that actually you can achieve comparability. The first step, of course, to achieve comparability, but doesn't mean that you can actually achieve comparability. Because remember, these standards are created by people. People have a way how they conceptualize reality. I always tell people, I think I sent you outside to create a topographic map. Most likely all of you are going to bring different types of different maps when you draw them. The thing is not only your skills that are at play, it's just your cognition, the way you look at things. Some of you can see a forest and you call it. The way you conceptualize things, it's not by the definition, but rather by the way you just look at things. Sometimes you may look at Allan and then you say, Allan is a big guy. And then another guy comes and looks at me, he says, no, it's not big. It's not big, he's just a small guy. Just because of the way we look at each other. It's not by definition, not by the qualities that I possess, but rather by the conceptualization. That means that even when you're defining your terms in a standard, this conceptualization has some kind of play. Now, if you get these two standards and you try to combine them, then you have issues. There's some bit of you can have different standards, or if you get these two different kinds of standard products and you combine them, then you're going to have. Now, at times, some of these classes are so narrow, others are so broad to be able to help you to do your classification. And also the cost of getting the data into a particular land cover classification system is always so high. So you'll always likely get this data when it's not in that land cover classification system that you wish to have in. So in that aspect, we've been able to, we are lagging behind in using this kind of way of harmonizing land cover classification system. Now, another way that I've used at least is the semantic interpretation. Very possible for you to constrain meanings. I've already told you for the different land cover classes. So you have your Korean, for example, and you have your Anderson. And whenever you search for data, you search for particular classes, it can be able to interpret those classes and convert them into another classification, then be able to get for you this data. Maybe to explain it this way, just assuming I have data that I put in the database from different land cover classifications. In semantic matching, it's very possible for you to query the database and say, for example, I need forests. And it's going to go into the database and also interpret the forests by the definition of another land cover classification of the two different land cover classification systems, and it's able to bring you whatever is a forest. Now, this also has had its own problems because we have different kinds of definitions in different disciplines. So different disciplines have different kinds of vocabularies that they use to be able to constrain meaning for the different classes. So that becomes a little bit complicated for us to be able to define using this kind of methodology, though it's possible to do it. Now, the other thing is that this always assumes that the land cover is already existing, land cover classification system. You go to the field and maybe you find out other kinds of peculiar kinds of classes. It's not easy for you to come back and try to work around your land cover classification system and then be able to harmonize. So that's also a problem with this kind of that has been faced with this semantic interpretation. Most of all, for you to be able to do semantic interpretation needs a lot of expert knowledge. just doesn't happen like that. There's a steep learning curve for you to be able to translate from one land cover class to another. Now, there are also issues with the legend. Legend, it's rather very difficult for you to be able to capture semantic relations from previous land cover classifications that maybe could be deduced from characteristics of the survey in the field. So I've been able to, like I've told you, I've already sent you, they are going to give you a journal paper. Just take a look at it so that you can be able to understand what a land cover classification system is all about. I've also provided here some typical exam questions. For example, why do we need a land cover classification system? I've already told you one of the reasons is because you want to have some form of standardization. How you define land cover classes, so that if maybe one of you gets an image and he wants to classify it, he's able to define the information classes in a way that another person can also be able to define them. That means that if you got these two data sets from these two different people, then you have some sort of comparability. And then you can also look at the different typologies of these land cover classes as well as the examples. Then it's very important for you to discuss the choice of the land cover classification system. Why should you choose a particular kind of land cover system? So different regions have different kinds of land cover classification systems. So you don't just wake up one day and say, I've created my own. The way you become so excited and you're like, okay, I've created my own classes in an image. No, it doesn't work that way. You need to go and look at a particular land cover classification system that's used in your area. So it's some sort of standard that is broadly accepted. Now, some of these standards are below, you have to classify land cover like ABC. Some of the standards are de facto. Many people have used that standard or that land cover classification system that it has become the one that you must use. So there are those kinds of standards. If you've used the shapefile, you'll understand that everyone thinks that a shapefile is a way of encoding, for example, geographical vector data. But the reality is that there are so many other classes. There are so many other forms. And now, no one tells you that you must use it, but rather it's because many people use it. So it's the de facto standard. I'm trying to explain the concept of de facto. Likewise, in land cover classification systems, there are some systems that are used commonly, but there is no law that says that you must use them. So those are de facto kind of land cover classification systems. Now, we've also discussed briefly how to harmonize the different land cover classes or land cover classification systems. And like I've already told you, is that we've not been able to achieve this fully because of particular reasons. Each of these methods has its own drawbacks. So we've said that you can basically have a standard terminology, but if you have standard terminologies across different kinds of information communities, then if you generate a land cover class, it's not going to be able to get harmonized with another or compare with another. And we say that also you can use the semantic harmonization of geospatial data, rather of this kind of geospatial data. We say that you need some bit of expert knowledge to be able to do that. And then we have also to know that different communities have different kinds of vocabularies that they use to be able to encode meaning. And we said the other way is to use the legend, where we have one legend expressed in the form of a particular kind of one legend in one classification system being played around with so it can accommodate the other land cover classification. I would say that that's also another way of analyzing this land cover data. So unless you have any questions, I'd like to end my lecture, but I'll just entertain some questions. With you, there is a journal paper that you have to read. Please, all of you have to read this journal paper. And then there is also a document for the National Biomass Study. And then there is this slide. So thank you very much.
Thank you very much, Allan, for that exciting lecture. And please, if there are any questions, this is your opportunity to ask them. I don't see any questions, so I will assume they have understood. All right. If there is no further question, we would like to bring this class to an end and have a great weekend. Thank you, Allan.